Good morning dear students. Let's start three-dimensional geometry. In today's session we will discuss about the second exercise of this chapter, and I have enclosed the basic concepts and working rule of the topics direction ratio, direction cosines, distance between two parallel lines and the shortest distance between the lines. Okay students, let's start with question number 1. Show that the three lines with direction cosines are mutually perpendicular. We have the direction cosines of the three lines 12 over 13 minus 3 over 13 minus 4 over 13 are the direction cosines of line 1. In the same way, these are the direction cosines of line 2nd and 3rd. We need to show that these three lines are mutually perpendicular. We know that two lines with the direction cosines are perpendicular to each other if L1 L2 plus M1 M2 plus N1 N2 is equals to 0. So we need to show that here this condition will be satisfied. So here let's start. Direction cosines of L1 are L1 12 over 13, M1 minus 3 over 13, N1 minus 4 over 13. In the same way, line L2 have direction cosines L2, M2, N2. So put these values in the condition L1, L2 plus M1, M2 plus N1, N2. By using these values, we get here 12 over 13 into 4 over 13 plus minus 3 over 13 into 12 over 13 plus minus 4 over 13 into 3 over 13. In this way, we get 48 over 169 minus 36 over 169 minus 12 over 169. By taking the LCM, we get 0 in the numerator. So, the condition satisfied L1 L2 plus M1 M2 plus N1 N2 becomes a 0. In this way, these two lines are perpendicular. In the same way, we solved the next two lines, line L2 L3 and line L3 L1 will also satisfy the same condition. Here L2 L3 plus M2 M3 plus N2 N3, in the same way we put the values in this, so we get again 0. So students, this is similar, so you can do. I am sharing you the solution. Hence the two lines are perpendicular. So here the given three lines are mutually perpendicular. Okay students, so आपको यहाँ से एक बात ध्यान रखनी है कि whenever they ask to show the lines are perpendicular, then in that case you have to satisfy the condition L1 L2 plus M1 M2 plus N1 N2 is equals to 0. So next question is question number 3rd. Show that the line through these points is parallel to the line through these 2 points. Here we need to show that the line joining these 2 points is parallel to the line joining the next 2 points. Okay, so in this way direction ratios must be proportional. So here we need to calculate the direction ratio. Direction ratios are x2 minus x1 plus y2 minus y1 plus z2 minus z1. So here two lines have direction ratios a1 b1 c1 and a2 b2 c2. These are parallel if a1 over a2 is equals to b1 over b2 is equals to c1 over c2. Also, a line passing through the 2 points has the direction ratios x2 minus x1, y2 minus y1, z2 minus z1. So here we have 2 points AB. Direction ratios of AB will be 2 minus 4, 3 minus 7, 4 minus 8. So here A1 is minus 2, B1 is minus 4, C1 is minus 4. In the same way, we calculate the direction ratios of CD. So students, by taking the ratios of A1, A2, we get minus 1. Taking the ratios of b to b1, we get again -1. So here you can observe that the direction ratios are proportional to each other. So in this way they are equal but opposite in sign. So therefore the given lines are parallel. Okay. So here next question is question number 5. Find the equation of the line in vector and in Cartesian form that passes through the point with position vector and in the direction. In this question, students, we need to find the equation of a line in vector as well as in Cartesian form. And here the position vector is given and the direction is given. First of all, you should know the method how to find the equation. Here r vector is equals to a vector plus lambda b vector is the equation of the line, where a vector is a vector that lies on the line and b vector indicates the direction of the line. And in the question we have a vector is the position vector, that means this vector lies on the line, and in the direction, here this direction denotes the b vector and this vector denotes the a vector. So by putting the value of a vector and b vector, we get the equation of a line in the vector form. This is very easy. Next, we have to calculate the same in the Cartesian form. Cartesian method is that x minus x1 over a, y minus y1 over b, z minus z1 over c, where x1, y1, z1 are the points that lies on the line and a, b, c shows the direction ratios. Students, if direction ratios are given, then we will put a, b, c direction ratios. If direction cosines are given, then we can also put direction cosines, because direction ratios and cosines are proportional to each other. So here we have equation of line passing through point and parallel to the direction ratios ABC will be this. Since the line passes through the point 2i minus j plus 4k, x1 is 2, y1 is minus 1 and z1 is 4. You will write here the scalar components, okay, of the vector. Here 2, minus 1, 4 are the scalar components. So also line is in the direction of I plus 2j minus k. By using these values in the Cartesian form, we get the answer. So here this is the equation of line in Cartesian form. Next we have question number 7. The Cartesian equation of a line is given. Write its vector form. Students, here equation of line is given in the Cartesian form. We need to calculate in vector form. So we only just required a vector and b vector, where a vector is a vector that lies on the line. So here 5, minus 4 and 6 are the scalar components of the vector a vector. 3, 7, 2 shows the direction. So here equation of a line in Cartesian form is given by this. On comparing, we get the a vector and b vector. So here equation of line in vector form is r vector is equals to a vector plus lambda b vector. Put the values of a and b, we get r vector is equals to 5i minus 4j plus 6k plus lambda 3i plus 7j plus 2k. So this is the vector equation of a line. Next question is question number 9. Find the vector and Cartesian equations of the line that passes through the points. Here we have only 2 points. We need to calculate the vector equation first. We know that r vector is equals to a vector plus lambda b vector is the vector equation, but here it is given b vector minus a vector. Students, यहाँ हमें direction लिखनी है. Okay, if points are given, then we find the direction ratios and that will be written in here in the position b vector minus a vector. So here vector equation of line passing through the 2 points with position vectors a and b is r vector is equals to a vector plus lambda b minus a vector. Given the 2 points are given. So students, here we have 2 points that are given. Take any of the point in the position of a vector, because both are position vector on the line. So we select a vector 3i minus 2j minus 5k, and next lambda, here we have the direction ratio 3i minus 3i, and same minus 2j minus minus plus 2j plus 6k minus minus plus 5k. By solving this we get r vector 3i minus 2j minus 5k plus lambda 11k. So in this is the vector form. In the same way we can calculate the Cartesian form by using the a vector in the place of x1, y1, z1, and by finding the direction ratios of the 2 points by subtracting the 2 points together. So student, this is very easy. In this way we have equation of line in the direction of 3 minus 3 minus 2 minus minus plus 2 6 minus minus plus 5. So 0 0 11 are the direction ratios, and 3 minus 2 minus 5 are the points that lies on the line. So students, hopefully all of you get understand the questions of exercise 11.2. So if you like my video, then please like, share and subscribe. Thank you for watching the complete video.